Greetings, fellow scientists. Welcome back to our channel and our series about physical science. In the previous video, we looked at forces and that forces can bring change to an object. We also delved into normal forces as well as friction forces. This video is all about Newton. Remember I told you in physics you will almost always find a rule? Well, in this case of force, there are three very important rules. I will help you to understand the basic principles of each rule. This section also requires some math skills. So you have heard me say this one before and you will hear me say it many times more. Study the rules plus understand the basics plus practice the maths equals acing physics. So, lab coats on and here we go. Let's see what the three rules are that Sir Isaac Newton formulated. Newton's first law. An object continues in a state of rest or uniform motion, motion with a constant velocity, unless it is acted on by an unbalanced, net or resultant force. Newton's second law of motion. If a resultant force acts on a body, it will cause the body to accelerate in the direction of the resultant force. The acceleration of the body will be directly proportional to the resultant force and inversely proportional to the mass of the body. Newton's third law of motion. If a body A exerts a force on body B, then body B exerts a force of equal magnitude on body A, but in the opposite direction. Before we go into equations and technical terminologies, I want you to try and figure it out for yourself by thinking of practical examples. Science is a very formal language and study. Sometimes it helps to make it as simple as possible. Look at the first rule on your screen. You see the word object, state, uniform, and net or resultant force. Intimidating, right? But here is what this sentence is actually saying. Your plate will keep standing still on a table unless you move it. And if you throw your plate, it will keep moving at the same speed unless gravity kicks in. That sounds much simpler, right? Let's do the same for the other two. Look at the law on your screen. If a resultant force acts on a body, it will cause the body to accelerate in the direction of the resultant force. The acceleration of the body will be directly proportional to the resultant force and inversely proportional to the mass of the body. What this means is, if you pick up a ball, it will move. And that would actually be enough to explain the rule, but the rest of the rule is simplified. When you pick up the ball from the floor, your arm will exert a pulling force directed from the floor towards your body. So, the next part of the sentence is saying, the ball will start to move at a speed towards your body. The ball will move with your hand at the same speed as your hand because of the effort or force you put into picking up the ball. The last part needs a little comparison. If you pick up a ball and you pick up a stone, the mass of the body influences speed at which you are able to pick up the ball or the stone. Next and last rule simplified. Look at the rule on your screen. Newton's third law of motion. If a body A exerts a force on body B, then body B exerts a force of equal magnitude on body A, but in the opposite direction. The rule can get a little funky because it is so logical that we don't even realize it exists. So try to bear with me here. If this law of motion didn't exist, We would, for example, sink through or walk through solid objects. Simple example, if you push an object against a wall, the object pushes back with the same force as your hand. Otherwise, your hand will go through it. So, for every action, there is an opposite but equal reaction. Now, please, don't use these Lara simplifications in your formal assessments. It serves only to show you how simple the concepts can be. You still need to formally tackle these laws with equations, proper terminology, and stuff. Okay? Let's look at the second law formally, quickly. Look at the key on your screen. Acceleration is indicated by a small letter A. It is measured in meters per second. The symbol is m.s to the power of -1. Force is indicated with a capital letter F and is measured in Newton, and the symbol is a capital letter N. Mass is indicated by a small letter m and measured in kilograms, and the symbol is a small letter K and G. Tension is indicated by a capital letter T, measured in Newton, and the symbol is a capital letter N. Weight is indicated by a capital letter N, measured in Newton, and the symbol is a capital letter N. The formula for the second law is net force equals mass times acceleration. How do we apply Newton's second law? This is basically stating, how will I be assessed? Force is a vector quantity, so you will be asked to identify the horizontal force on an object. You will also be asked to calculate the magnitude and the direction of the total frictional force of an object, or the tension in a rope, chain, or string, for example. In this example, you will need to get values for all the forces involved and apply Newton's second law. You might have to calculate the horizontal component of an applied force to an object, and in most cases, the acceleration of the object. These questions can be answered by using the formula of force equal mass times acceleration. Where things get a little more interesting is when we have an object on an inclined plane. If you have an object on a horizontal surface like a table, and the surface is lifted, the surface will start to incline. In other words, the angle will increase, and the gravitational force will start taking effect. As the angle of the surface increases, the gravitational force will increase. The object will start to accelerate when the gravitational force becomes larger than the frictional force. You know that when you see the word angle, you know Pythagoras is entering the building. You will need to use sin and cos to calculate the angle. A term you might come across in this body of work is equilibrium. This means if an object is in equilibrium, the sum of both the forces acting on it equals to 0. Meaning, if an object is stationary or moving at a constant velocity, then either no forces are acting on the object or the forces acting on the object are exactly balanced. Weight and mass. Mass and weight are not the same thing. Mass is a scalar and is a measure of how much matter is in an object. Your mass is the same everywhere you go because the amount of what you are made of doesn't change. Weight is a vector and is a measurement of how hard gravity is pulling on that object. You will therefore weigh less on the moon because of the gravitational pull. This concludes our Channel 11 series on forces. Stay grounded. Lara out.